exciting game of catch. The first book is kind of topical, iPhone Forensics. The second book from No Starch Press, The Art of Debugging with GDB, DDD, Eclipse, and this one's heavier, so watch out. Oh, man. Sorry about that. Everyone okay? Last year, Charlie Miller spoke to Shmoocon about Second Life, and this year he is back to talk to us about defeating Android.
Is there like a... Is this mic part? Looks like... So I guess Android's not as interesting as botnets, but it's still kind of interesting, I think. So, can you hear me? Can I talk? Okay, cool. So I'm going to talk to you about Android. Who am I? Besides speaking last year at Shmoocon, which was a highlight of my career. I used to work at NSA. I was the first to hack the iPhone and the Android G1 phone. I won the Pwn competition last year. I wrote a book about fuzzing, and I wrote a book about hacking Macs, which is coming out in a couple weeks. So you can buy that, and I'll make like a quarter from it. Okay, so what am I talking about today? Phone hacking and why it's interesting. Android, of course. Then I'm going to talk about so what Android does, and to try to stop you from being bad. And then I talk about what the bad guy can see on the phone, so what he has access to. How to find bugs in it, how to write exploits for it, and then what you can do once you've exploited it. All right, so first, sort of basic stuff. It's not really Android specific. So why is it fun to hack phones? Or why, if you're work for a corporation, why is it a dangerous thing that these people are carrying around these phones? So all these smartphones are just little computers you can carry around. They're always on, and until they run out of batteries. They're supposed to be always on. People carry them around wherever they go. They're always on the internet. So even if you're not in Wi-Fi, there's going to be, over the radio, they can still get onto the internet. And not only are they little computers, but once you take them over, they also have extra features. So they're like computers plus extra hardware that you can play with. So, just like, sort of one of the goals of bad guys when they take over computers is to steal personal information, and that's the same thing with phones. So people keep a lot of personal information on their phones. Their address book, saved voicemails, pictures they took, movies they downloaded, cookies and web credentials, email, text messages, their calendar, and GPS stuff. So the bottom is some pictures that when Paris Hilton's sidekick got broken into, they stole some pictures off hers, and those are some pictures that I could actually show. She had a habit of taking pictures of herself naked for some reason. It's like, I don't think I have any of those pictures on my phone, thankfully. Okay, so why else are these things, from the hacker perspective, why are these interesting devices to take over? Well, you've got this concept of a smartphone denial of service, which I'll talk about in a second. The other thing is you can instantly start to either make money or to cause the victim to lose money, or both. So you can imagine like 1-900 numbers or something. You can have the phone start dialing those, and it's going to hurt the person. If you're mad at them, or it's like your ex-boyfriend or something. You can make them send text messages. So I watch a show, Top Chef, and you can send text messages to vote for your favorite person or whatever, and it costs $1. So you could just start firing those things off, and not only do you get your favorite chef, to survive, but also it costs the person like $100 or something. The other thing is these things on this one, I don't know. I've only watched it. I think it just started, so I don't know if I have a favorite yet. Great question though. So they also have GPS on them, so it's kind of interesting because normally a bad guy takes over some random IP address and they don't really know where it is. But here it's totally opposite. So you can find out exactly where the the phone is, and you can follow it around and stuff. And I'll show that later too. The other thing is you can basically turn them into listening devices. So you can take over someone's, some CEO's phone while they're hanging out at Starbucks or something, and you just wait until they go into the boardroom and you turn on the mic and you can listen to what they're talking about. And finally, they sort of circumvent normal network security precautions. So usually you'll have like IDS or NIDS or something to listen to traffic and try to find when bad things are going on. But here, you can do everything over the cellular network, and so you sort of avoid that. Right, so what's this thing about phone DOS? So you can imagine if you had some sort of exploit against Android or some other phone, and you took over like thousands of these things, you could have a little botnet of them, and they can still do denial of services the traditional way, send web requests or whatever, and you can take over, or you can cause degraded service to some web server somewhere. But you can also have them all dialing into the same phone number too. So you can knock someone's phone system offline basically doing this. So it's sort of 2 for 1 you get. So it's sort of from a hacker's perspective, if you want to build a botnet, it's sort of better to build a botnet of phones than of normal computers. You can do more. This is an example. This is for iPhone, but it's the same concept. So this is an example of the way to communicate out of band. So I have this program for my iPhone that I can send it text messages, and it just routes it to a shell and gives me the command. So I have a remote shell that I can communicate not over the internet, just over the cellular network. So there's no way that a corporate intrusion prevention system is going to be able to detect this, but I can still access it.
What's your phone number?
Why is it I don't actually run this all the time, but here's my phone, so I'll know if you start doing stuff. Okay, so I already mentioned some issues for defense of phones, but here's some more. So the other thing is most computers have AV, which gives some sort of at least low bar of protection, but you typically don't get that on phones. I already talked about how you can avoid NIDS, so that's an issue. It's sort of tough to determine if a phone's been compromised. So most people don't have like a shell on their phone, so you can't easily see what processes are running, what the file system looks like. So it's kind of tough to tell if something's gone wrong. Forensics are kind of hard because people, forensics experts aren't real familiar with phones as they are with computers. And like I said, it's tough because while your corporate desktop is sitting at a computer, at a desk somewhere, and that you can control, the phones are always going around. They go to the person's house, they go to Starbucks, whatever. So you don't have sort of as good a feel for them. All right, so that's phone stuff in general, and why at least I think phone security is interesting. Now let's move on to what I'm supposed to be talking about, Android specific things. And most of the next few slides are basically generally available stuff on the internet, nothing that like I invented or anything. So what's Android? It's open source, free mobile platform. So right now there's only one phone that runs it in production, the T-Mobile G1 phone, which I have a couple here if you want to see them. There's a lot of vendors are saying they're going to make this, and it's supposed to be really big, but so far that's it. It's basically an operating system, middleware, and then some apps. It runs on a Linux kernel, and the web browser is based on WebKit, which is the browser that's in like Safari and Chrome. All right, so it's it's your typical smartphone that does everything. So it has 3G, Wi-Fi, Bluetooth. I already said it has a full functional web browser, SMS, MMS. It can play audio, video. It has an AOL IM client. I already said it has GPS, and you can integrate that with Google Maps and see where all your friends are and all that stuff. So it does basically everything you can imagine. What about the security on the thing? Well, it has two basic ways that it does security. One is by just using the traditional Linux security, so user IDs and that sort of thing. And the other one is it has some fine-grained access controls. I'll talk about both of those here. So what about the Linux-based way? Well, every application gets, whenever you install an application, the operating system creates a new user ID for that application, and then the application runs as that user. And so all the data that application writes to is owned by its own user ID, and so other applications can't read or write to it unless it gives permission to do that. And so here's a PS listing from the phone, if you can see. On the left is all the various applications. So they're called like app underscore some number. And you can see they all have different application numbers. So it's a pretty good idea, I think. And actually, when I broke into the iPhone, I said that this would be like a great idea. But I don't think they actually listen to me. It's just a coincidence. So what about this other way they do things? Well, there's also these access controls. When you download an application to install, or the ones that come on the phone, it'll say this application needs to access the internet and use GPS and use your address book. Is this okay? And so the user gets the choice to say, yes, that's exactly what I thought it was going to do, or no, why is Pac-Man need to access my GPS? And so they can choose whether to install it or not. But once they say yes, then it can do all the things that it said it can do, and it never asks again. And on the phone, you can type, there's this PM program that will tell you about the permissions that are allowed on the device and the various permissions that exist. And if you try to do something if your application tries to do something that it's not allowed to do, it didn't specify it was going to do, you get the security exception thrown. All right, so I'm like really big into browser security. Well, actually, I don't know much about browser security. I'm really big into like breaking into browsers. And so I said, well, what permissions does the browser have? Because that's what I'm going to get. And the way you do it is you can use these various programs that come with the SDK and find out. So first, you grab the browser.apk file, which is I'll get to this in a minute, but it's basically a Java bytecode file. And then you can dump out some of the contents of that Java file. And one of them is this thing called Android-Manifest.xml, and that's the one that contains this information about the permissions. So these are the permissions the browser can have. So if you break into an Android browser, this is what you're going to be able to do. You can authenticate to Google. You can get course and find location, which is GPS. You can do some download manager. I'm not sure exactly what that is. You can find out the network's on, if the Wi-Fi's on. You can install shortcuts. You can access the internet, and you can wake the thing up. So that's what you can do. So for example, you can't read SMS messages. You can't read contact or mail. You can't read the address book. So there's a lot of things you can't do, even if you break in his browser, unless you figure out some other tricks, which I'll talk about. So I want to see what it looks like in action. So if you had a browser exploit, which I'll show you later, you can do this. So you type ID, it tells you your ID. I'm not root, I'm app1. So just like I think the browser is important, they must think it's important too, because it's the very first app. So I try to read the data directory, can't do it. I try to read this database about the phone, can't do that. I try to look at the system log, can't do that. So there's a lot of things I can't do. All right. So now what about what's all about these applications that are running on this phone? Well, you can get an SDK for it. It's free. You can download it. It comes with an emulator. The thing that not everyone knows is all the applications on here that you can write or download are all actually Java applications. So you can't write C code in a supported way, at least. So it'll only run these signed APK files. So APK is like a jar, but you can self-sign them. So the signing doesn't actually give any security. It's just sort of for bookkeeping. And unlike the iPhone, like the applications can basically do anything. They can run in the background, run the whole time, do whatever they want. But they are Java apps. So you can do C, but you can't do it in a supported way. But if you want, you can get just a generic ARM cross-compiler. They have a non-standard libc, so it's sort of a pain. It's called Bionic. So the debugger that comes with the SDK is pretty worthless for this because it's actually a Java debugger, not an actual C debugger or whatever, a real debugger. So here's an example where you can, if you build something statically, it'll work fine with a generic cross compiler. So I build a program and I run it on the phone and it works. If you want to do it dynamically, it's a lot harder because of this whole strange libc that they have on their phone. But you can do it. So the way to do it, I outline here. So you have to download the source code and build it for the whole operating system. It comes with a compiler. Use that. Then you can get this. It's basically just a trick of sending in the right flags to GCC. And someone wrote this AGCC wrapper, which sends in all the right flags for you, so you don't have to worry about it. So here, if you can read it, in the first little code snippet thing, I try to build it dynamically with just the generic cross compiler with nothing fancy. When I try to run it on the phone, I get this error, hello, not found, which is like really strange because like it's right there. But what they're trying to tell me is they couldn't find the library it was looking for. And then I use AGCC to build it, and when I run it on the phone, it works great. So you can do dynamically linking, it's just a little harder. But again, you're never going to get this stuff into the Android market or whatever. This is just for your own personal fun and games. All right, what about firmwares on the thing? So it's a relatively new phone, and so I can actually outline all the firmwares that have ever existed. So RC19 was the original one that came out of the factory, and it's the one that had the old WebKit bug that I 1.0'd with, and so I own this guy too with it. RC28 started coming out, just with some fixes, but then I told them about this WebKit bug, so they stopped that and they pushed out RC29 before like everyone even had RC28. RC29 has this like really interesting local root bug that I'll talk about, and then RC30 fixed that. And then just this week they started rolling out what they call 1.1 or RC33, which is just another upgrade, which of course has all the bugs that are fixed. So that's the current one, RC33. And then they've got some British versions, and then they've got the developer phone version too, which is like somewhere in the ballpark of RC28. Okay, so you can actually download different firmwares and flash your phone with them, and this is how you do it. You can download the file. You have to put it on an SD card on the phone. You press some magic buttons, and you get the little screen on the right, upper right there, and you can actually put whatever firmware you want on it. It's pretty cool. Okay, so let me talk about this root bug that someone found on the RC29. It's like sort of the most interesting bug, I think. So basically, they have this. So the whole like bug boils down to these two lines that they put in an RC, which I guess they forgot to take out. So what it says is basically there's always a console that just runs everything you type into bin.sh. So if you just take your phone and you like you say you're searching for a contact and you search for the contact reboot, it'll just reboot your phone. So it's like really cool. But what people do to make it useful is they type telnet D, and then it runs telnet as root, and then you can just telnet in and you're root. So that's what you do. I mean, it's not like a real security issue because you have to like have the phone, so you already have the phone. But it's cool for us, like hacker types, because then we have root on our phone and we can do stuff to play with it. All right, so let's see, do I have one more? Okay, so the point is, if you want to like play with your phone, you can downgrade. Did I already say that? I guess not. But anyway, you can downgrade your phone to RC29, which has the bug. You get root, and then they have modified versions of the newer firmware that don't take away your root that you can get. But if you put the real firmware, then you don't have root anymore. Anyway, so I have root on my phone. Okay, so that's the basic stuff, and now we're gonna get more into what an attacker can do. So we'll talk about like what parts of the operating system are accessible to a remote attacker on the server or the client side. Okay, so on the server side, there's not much, which isn't too surprising because it's not really supposed to be a computer; it's a phone. It listens to Bluetooth. It listens for wireless connections. It has like a TCP/IP stack and so forth, but basically it's just all really really low level stuff. It has no listening ports on UDP or TCP, except sometimes you'll see this 5555 if you're messing with it, but you wouldn't see this like on your friend's phone if he wasn't like a master hacker or something. So here's proof is I run netstat and there's basically nothing there besides what I've actually like connected it on. Okay, so basically you're not going to find a remote exploit against it from just the server side. Yeah.
There was a port 5037. What is that?
So I don't know, but I don't care because it's bound to 127.0.0.1, so I can't access it. But yeah, I don't know what it is. Yeah, but it's not. You wouldn't be able to access that remotely. Is what I'm saying. So on the client side, there's like tons more, which is typical. So you've got the web browser, an email client, IM client, SMS, MMS, multimedia player, whatever apps you download from the marketplace, and whatever else you find. So there's tons of code that you can get to if you can make the guy, the victim, come to you. But then, like a lot of people say, oh, but all the apps are Java, so, they're untouchable, right? Well, yeah, in theory, that's true. So, you can't have memory corruption in Java. So they're like totally safe. But of course, the JVM, and they have a special JVM called Dalvik, I think is what it's called. And so they don't use the Sun one or anything. But anyway, so all their like libraries that all the APIs in Java end up calling down into C code eventually. And so, all the libraries are basically written in C. And so as long as you can get down to one of the libraries, you're fine. And sometimes it's even worse. So they have some daemons that run on the phone to handle stuff that are written in C. And all the Java API does is pass data to these C daemons to process. And I'll show you this in a bit. Okay, so what libraries might you have access to that are interesting? So there's this libc thing, Bionic, that they have. OpenCore is what they use to do their multimedia. Now it's open source. I don't think it used to be. SGL is their image rendering library. WebKit, of course, I've mentioned, does HTML, JavaScript, and other web-related things. And all this stuff is open source and written in C. So if you can find a bug in any of this, you can probably get to it through a browser or through SMS or MMS or whatever. Okay, so that's what a remote attacker can see on the phone. Now let's talk about how you would actually look for bugs in that. So we've narrowed down what code to look at. Now let's talk about how you would find a bug in that code. So there's basically two ways, and this is basically just like any time you're looking for bugs. There's two ways to do it, right? You can look statically at binaries or source code, or you can dynamically run the thing a bunch of times and see if you can find a bug that way. All right, so what if you want to look at it statically? Well, you can just download the source code and you can just read through it, or you can build it and run it through tools, whatever you want. So you can do whatever you want. I get the question a lot, like, well, it's open source. Does that mean it's more secure, less secure, whatever? And I always say, well, it doesn't matter, right? Because, at least in my opinion, so Microsoft has issues throughout their career, and they're not open source. Like Apache is open source, but like I don't think there's been a bug in 5 years that's useful in Apache. So I think anyone can do it right, anyone can do it wrong, and it doesn't really matter. For me, like I don't really do stack analysis so much. When I usually do dynamic, and so I like to have the source code because once I do find a bug, I can look at the source code and figure out exactly what it was, where otherwise it's kind of hard. Okay, so here's an example of what you can do with the source code. So again, like my first thing I want to do is dynamic. So I want to know like what kind of image files will the browser render, because I want to fuzz those. And so you can look through the source code, and so you can look through the libsgl code. Like I say, it's interesting, and it happens to also be buggy. So there's this one file that has this line, this little blurb in it. And it tells you exactly which image formats the browser supports. So GIF, PNG, ICO, WBMP, BMP, JPEG. So there you go. It might be hard to figure that out in a binary, but with the source code, I know exactly what I need to worry about. So I don't have to worry about fuzzing like some other format. Okay, so then you can just sit down and read the source if you want. So here's the source code for the ICO files, image files. And this is just sort of, it's not like a super security issue probably, but it's just sort of funny because it's like so obvious. So here's some source code. This is the function that's called when you give it an ICO file to parse, to render to the browser. The first thing it does is it reads in this buffer, and then it starts picking off bytes and doing things with them, right? So one of the things it does, so ... so it does some stuff. And then one of the things it does is it says read 4 bytes. So it reads 4 bytes at some offset from the data you've given it, okay? Then the very next line, it says read 2 bytes at that offset. So you could give it any number you want, like 1 billion. And instead of reading within the buffer, it's going to be reading some random place in memory. So it's a what they call a wild read, right? Oh, it's a wild read, period. Right? Question mark. Okay. So the point is it's like come on, that's the lines are adjacent. Can't you see that there's an issue here? So anyway, that I don't think you could like take control of the thing or anything, but it's still just sort of funny. It's cute. Okay, so that's the source code. Now onto fuzzing. So I probably don't tell you this, but fuzzing is when you just send in like a ton of test cases to the thing, and each test case is like a valid file, except it's been mutated just a little bit. And hopefully it'll find some corner cases, and the thing might crash or it might not. Okay, so that's fuzzing in two senses. So what about fuzzing Android? Well, there's a couple ways you can do it. So Android comes with an emulator, which I'll show you. The emulator is like, it's probably like the best phone emulator, I think, that's out there, in my opinion. So it's based on QEMU. The processor is ARM, just like the phone. So it's exactly like the phone. You can actually take binaries from the phone and stick them on the emulator, and they work. It has the full Android operating system on there. It's not updated like the phone so frequently. So like, for example, the WebKit bug that I pointed out to them on the first firmware, but then they fixed, they haven't fixed in the emulator yet. So it's not exactly the same anymore, but it's a good starting point. And so you can either fuzz the real phone or you can fuzz the emulator. And just so you have to make sure, obviously, if you find a bug in the emulator, you have to verify that it's actually on the phone, because if you own the emulator, who cares? All right, so what's some more information about the emulator? So fuzzing the emulator is like really nice because, first of all, you don't need to actually go buy a phone to do it, right? So you could give a whole security talk on Android without even owning one. You can also do things like stick the emulator inside VMware and take snapshots of it, so you can restore the operating system to a previous state, and part of that is restoring the emulator here to its previous state. You can even do exploit development on the emulator if you want, and I'll talk a little bit more about when you might get into trouble doing that or when you might not. And then if you really mess up the emulator, which I do frequently, if you run this emulator wipe data, it sort of restores it back to its factory settings. All right, so Android comes with this ADB thing, the SDK I should say. It's called the Android Debugging Bridge, and it's a way to do debugging actions on the phone. It allows you to push files onto the phone, pull files off the phone. It'll give you a shell that you can do things on the phone with. On the emulator, the shell gives you root. On a real phone, it only gives you this user shell, which it can't really do anything. Except actually kind of what you want to do, and I'll talk about it. So the other thing you can do is you can watch system logs, which is really useful. All right, so let's see ADB using it in action. So hopefully you guys can read that. The first thing I do is ADB devices, and it tells me all the devices I have attached, which it happens to be my G1 phone. And then I do ADB shell, and I type ID, and it tells me I'm user shell. Just what I said would happen. And then you can do this ADB logcat. It's this great little program that just starts, it's like a tail minus F on the system log, so you can see what the phone's doing. And it turns out that when any of the applications crash, they report that in the system log. So if you're fuzzing, all you have to do is watch this logcat, and you'll see when something's gone wrong. And that's one of the hard things to do in fuzzing, is to know when things have gone wrong. So you don't have to worry about attaching with a debugger and all that stuff. You can just watch the logcat. Okay, so let's actually see some fuzzing, right? So if you want to fuzz the browser, it's pretty easy because you can use HTML and JavaScript and so forth to do the fuzzing. So I have a little snippet of HTML there that does meta refresh to keep the browser going back to the same page over and over and over. And then you just sit back and you watch for crashes. So let's see an example. Okay, let's see here. So here's the emulator. And here is a shell. Okay. So in one window, I'm going to run logcat. Oh, I think I already am. Okay, I'm so organized. And the other one, I'm going to run a fake web server. So all this does is this web server has the property that if you go back to the same page over and over, it always gives you a different image. So it's useful for fuzzing. And then I'm going to browse to my fake web server. Okay, so it just, like every second, it's just downloading a different ICO file. And then you can watch over here in ADB that it's just saying things that it's doing. Do, 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 do. And then you can watch, oh no, what happened? So the browser has become unhappy and went away. And so what the ICO files I was using here are the Codenomicon files. This is a company that makes fuzzing test cases. So I can personally guarantee that the Android folks did not use Codenomicon, or else they're really bad security people, which they're not. So okay, so you get this kind of thing in the logcat. So it says com.android.browser got a sigsegv at this address, and it crashed in libsgl.so, which remember was the image processing library, so not surprising. Okay, so there, I fuzzed, and if you look, I sort of cheated. So I started on, it's not cheating, it's showmanship, right? So I didn't start on image number 1, I started on image number 48. So I saved you watching the first 48 images, but image 53 crashed it. So I didn't save you much time. So you can find bugs pretty quick doing this. Okay, so that's fuzzing the browser. I don't know if it's going to start. All right. Okay. All right, so that's the browser. It's pretty easy to fuzz because you have HTML and stuff. It's harder to do something else. Like I want to fuzz the music player. So it turns out you could actually almost do it in the browser, because if you surf in the browser to, say, like an MP3, it'll actually automatically launch the music player and play the MP3, which is why that's on the attack surface. But you lose the ability to do like meta refresh when you do that. So you have to figure out a new way to do it. In this case, I'm going to try to launch the music player from the command line and tell it an argument, like which file to play. It's slightly hard because the phone is not designed at all for launching these things on the command line. You have to sort of figure out a way to do it. And it's all bytecode, so you have to launch it all within this virtual machine. So you have to fire up the virtual machine with the right bytecode, with all the right magic, and it'll work. So this is how you do it. The first thing you need is, for whatever Java app you want to run, you have to figure out what they call is the action and the component for it. And the way you do that is, again, you can get this Android manifest.xml file, and it's in there. So if you can read that, it says I'm dumping out the Android manifest.xml file, and you can see the actions. So the various actions at my disposal are create, shortcut, edit, main, media button, pick, search, and view. I want view because I wanted to look at something. And then to get the component, again, I just look in that file for a different thing. And the component in this case is called stream starter. So I want to view stream starter, and that's what I need. Okay, and here's a little Python script that will launch the app and print out what logcat says. So basically everything you want with fuzzing. And so I use this AM program. AM start minus A, the action view, minus N, the component stream starter. So if you just do that, it'll actually launch the thing. And then, like I said, it'll print out the log dump because it's this really great Python script. Okay, so let's fuzz that. All right, so oh look, see, look, hold on a second. See, my super cool web server has realized 5 minutes later that a crash has happened. Okay, let me get out of here. Okay, so this one, all I do is I run my Python script. And I start watching. So it'll automatically fire up the music player with a different MP3 each time. Hopefully. Doesn't actually seem to be working. There we go. If you're sitting in the front row, you can hear my MP3. So anyway, it'll just keep like every second doing that over and over. So this is what mostly fuzzing is like you kick back and you watch TV and you bill your clients for it. And again, for showmanship's purposes, it should actually, something should happen at some point here. I think it's this guy makes it angry. Okay, so let's look and see what's been going on over here. Okay, so yeah, something bad happened. My screen's not really big enough at this resolution to see. Okay, so it didn't actually do anything as interesting as I hoped, but you can see it crash. So it says, it starts saying things like, where did I see it? Actually, I don't really see where it says anything bad happened, but something bad happened, believe me. Let's try it again. I don't know if it'll work if I run it again, but let's try it. So I'm going to talk a little bit about this file that it eventually gets to here, and why it's bad. And one of the interesting things about it, one of the things that makes it interesting as a crash is that you run it at different times, different things happen. And if you know about like exploit development, that means that something like really interesting is happening. These are just regular MP3s that I've just flipped bits in and stuff. So they're not like commercial ones or anything. Okay, so this time something more interesting happened. I can't see the bottom of my emulator. Okay, well anyway, let's look at Logcat here and see what happened this time. Okay, so this time it says system bin media server died, and this is one of those daemons I talked about that runs and accepts input from the Java programs. It died at this address, which is like, interesting looking. And it died in libc, which is like a really bad sign because libc is where it does the memory management. So that means there's probably been some sort of buffer overflow. And in fact, that's the case. Oh wait, not emulator. Okay, so that's fuzzing. So if you sit back long enough, fuzzing these things, you'll find all these bugs. There's lots of bugs to find. Okay, so now let me talk about that last file I just showed you. So this thing is, so I told Google about it 17 days ago. It's still actually a bug in the G1 phones today. They haven't patched it yet. So if your friend owns an Android phone, you have a short window where you can own them here. It happens in the lib.pvp player code, which is OpenCore's library. And it happens in this particular function. So PV MP3 Huffman parsing from this Huffman parsing C file. And I'll show you exactly what the bug is. Okay, so this is C code from Android. So it's parsing this MP3 you've given it. And I've sort of highlighted the important parts. I is being incremented by 2s based on something you've given it. And then it gets this gr bits variable from this length that you've provided it, so you control this value. Then it goes through this while loop, incrementing I by 4 each time, some number of times, it doesn't really matter. And then the interesting thing is this final thing, what happens. So it turns out that this Huffman PVMP3 Huffman quad decoding function is basically, it copies 4 bytes, 4 D words into this is variable, which is like the second argument. So at is of I, it's going to write 4 D words, where I is this value I've been talking about. And I happens to be a static, or not static, an array of this thing that it's checking for. So filter bands times subbands number. That's how big it is times the size of a UN. So the bug basically is that you can imagine a situation where I is like 2 less than that value, right? Than the size of the whole thing. So it passes that check, but then it writes 4 D words instead of 2. So the code basically assumed that I was going to be divisible by 4 by the time it got here, but that's not always the case. Sometimes it's only divisible by 2. So you can get it to where it writes 2 D words past where it's supposed to write. And this is just more explanation of that. So this is a UN array of that size. That quad decoding writes 4 D words. I control length. I can write 2 D words past it. I can own it. But then, like so I report this bug, right? And like CERT knows about it and all this stuff, right? And they're like, people like to say, oh, it's not exploitable though, right? Oh yeah, it's bufferable, it's not exploitable. So, and I didn't write an exploit this time, but like I want to prove that it's exploitable at least. I want to do the minimum amount of work I can do and still, still be able to talk about it. Okay, so here's some evidence I have that I think it's exploitable. So what I did was I just basically, so I had this one test case that crashed it, right? So I had taken a good MP3 file, I changed 1 byte, and it crashed. So I just said, well, what if I try some other byte values, right? And so here's some outputs from the system log for other byte values that I tried. So this one's actually really similar to the one that we actually saw here live. So it crashes in libc at this particular address, and then real little in the corner there is a little idapro dump. And what's going on is so I don't know if I even mentioned this, but I haven't yet. But basically, the Bionic libc it uses Dougley for the memory management. So it does the safe unlinking. So it makes sure that like the forward, if you go forward in the linked list and then back, you end up where you started from. So it's nothing crazy has gone on to the linked list. And this is basically the code where it tries to go forward and back, and it crashes because the metadata is all screwed up. So it goes forward to some random spot, and then when it tries to dereference the backwards pointer, it dies. So this is sort of proof that you can overwrite heap metadata, which is bad. Okay, this is another one that I got. So and this one, it crashes somewhere in the lib.pv player at this particular address. And the important thing is to realize that R6, like we have some control over that. And let's look at the idapro and see why it crashed and what you could do if you changed R6 a little bit. So if you know your ARM assembly, like I'm sure we all do, basically what happens is it takes R6, adds C to it, dereferences it, right? So dereferences the thing we control. So you can imagine we point that into something, some data that's ours. So it reads something, it dereferences that and reads it into R0. Then it dereferences that and puts it in R3. So again, you can imagine that we're still controlling that. And then it dereferences that and puts it into R1. So again, we're sort of controlling that. And then it branches to R1. So that's like the equivalent in x86 of like jump that. So basically at that point, if you were clever with what you chose for R6, you would have control of the program counter. So you get control of the system this way. So if you're clever with R6, you can own it right here. Okay, but then this was my favorite one. So I was just fuzzing, right? So it's one of these things. I set the thing. I go downstairs and I watch some TV show, and I come back upstairs and I look at the reports. And this one, it actually almost owned it all by itself. It cracks me up. So somehow it got control and started executing on the heap. So it almost got control even by accident. So I like that one. But anyway, I think if you don't believe by now it's exploitable, then I haven't done a very good job of talking to you. Okay, so we now know sort of some Android basics. We know how to find bugs, and what about writing exploits, right? So from an exploit perspective, it's basically just the phone is basically just a Linux box that runs ARM. I already sort of gave away the secret, but the Bionic library is, from an exploit development perspective, is not special. The memory is going to look pretty much just like you would expect because it uses Dougley malloc. You can almost use just standard shellcode, Linux ARM shellcode that you would find on the internet. I'll show you the one little difference. You are, of course, once you get on, you're limited by the sandbox. Okay, so let me tell you about the very first exploit I wrote for Android. So the SDK came out like way before the phone. It had a ton of bugs, and other people reported those. So the PwnGnome bug that I used was in the SDK, like leading up to the phone's launch, and I was So I wanted to know whether it was just in the SDK or whether it was really going to be on the phone. So I got a hold of a phone and found out it was on the phone too. So I told Google, and then the phone launched. I told some reporters about it, but I didn't tell them what it was. I just said, hey, there's a bug. They fixed it. Everything sounds great, right? The only reason I bring this up is because I'm still sort of like hold a little grudge, because if you read the actual newspaper article that came out, it's like very critical and saying like, Charlie Miller, he broke the secret law of bug finders by telling someone about it, right? I didn't tell anybody anything except there was a bug. But anyway, so just like here. Well, here I told a little more than that. Okay, so this is what an update looks like on the Android phone. So basically all the updating happens automatically over the T-Mobile sends it out over the airwaves here. And it'll say like, hey, there's an upgrade available. Do you want it? Yes or no? Okay, so then if you're really careful looking at the timeline, like the phone launched on the 22nd, but I was already reporting it on the 20th. How'd that happen? eBay, right? So actually, like a week before it came out, I looked on eBay, and people, like this guy at least, was selling a G1 phone before they were even released. It was pretty cool. So I sent him an email because I thought it might be a scam, and I was like, how come you're selling, how did you get a hold of one of these G1 phones, right? Is it legit? Is it the same thing that they're going to have, in a couple days? And he's like, oh yeah, I work for T-Mobile, and they gave us some. I was like, okay. So I bought it. So so I had thanks to eBay. I scratched out the price because I paid an embarrassing amount for it. More than it cost in the store. And then the other fun that I had was, so I get the phone, right? And it's before the launch, and I was like, oh, I'll just turn on Wi-Fi and hack on it, right? But I couldn't, because as soon as you turn it on, the first thing it says is, oh, I want to log into the Google servers and log you in and stuff. And I want to do this over the your T-Mobile account. I was like, ugh. So I'd call T-Mobile, hey, I just got this phone. I wouldn't tell them it was an Android phone, right? I was like, I got this phone, I want the data plan. They're like, oh, we've got like 20 data plans. What kind of phone do you have? And I was like, oh. So I was like, whichever one is sort of the most general. And so so they signed me up for that. They're like, it'll take a day until it kicks in. So I waited a day, phone doesn't work. I was like, crap. And then I tried one other one, and it didn't work. And then finally, like, it was getting closer to launch date, and I was like, okay, here's the deal. So every time I call up, I tell them a different story. I was like, okay, here's the deal. I'm going to get one of these Android phones as soon as it comes out, and I want to make sure that as soon as I get it, I'm on the right plan, and it's just going to work. I don't want to have to wait a day. Like, oh, okay, we have this plan called the, like, pre-release Google phone plan. I was like, oh. I was like, I want that plan. And so sure enough, like, the next day, it worked. So then I was able to get on, and the only thing I did was I didn't even make a phone call. I got on, I turned on Wi-Fi, and then like I pull my SIM card out, and then I can do what I want. But anyway, so it was a tangled web of lies, I'm afraid. Okay, so I gotta finish this up quickly, but luckily I'm almost done. So the main point I want to make here is that Linux exploits look exactly like our Android exploits look exactly like Linux exploits. And here's an example. So I know iPhone's not Linux, but if you do a diff of the Cansec West Pwn gnome bug for iPhone and Android, there's only three lines in the exploit that are different. The shellcode, of course, the data that writes over the metadata, and of course the address of where you expect your sled to be. That's it. That's the only difference. And if you actually had like a Linux exploit version, probably the only thing that would change is the address. So writing exploits for this is no different than writing Linux exploits. Okay. As far as exploit dev in the emulator, my original exploit I wrote that I was talking about, I wrote in the emulator, of course, because I didn't have the phone, and it just worked on the phone. So if you write really robust exploits, and you write them on the emulator, some addresses and stuff will be different, but it's basically just going to work. All right, so quickly, if you want to know, a little bit about ARM, it's RISC architecture. Depending on whether it's thumb or ARM mode, you get 2 or 4 bytes instructions, 16 registers, arguments go in. This is mostly just for if you look it up later. Arguments, at least the system calls, go in R0 to R4. Those are the names of the registers. And then the stack, and this is called number, goes in R7. So I won't, this is again just sort of more for reference. But basically this is the shellcode I used, and it's basically just standard connect shellcode. The only difference is instead of launching bin sh at the end, I launch system bin sh, which is where the sh is on the Android phone. Okay, finally a demo of an exploit, what it looks like on a phone. So I don't know if I'm gonna actually be able to do it on this resolution. I can't get a web browser back up. Come on. How do I get to a web browser? I might not be able to do it for you guys. Here, or I can do this, watch. Okay, you guys aren't seeing anything for a second, but then I'm gonna launch the browser and I'll put you back. I'm so clever. Okay.
Are your slides going to be available?
Yeah, I'm gonna post them somewhere. I haven't figured out where yet, but I promise I will. Okay, so now, let me make sure I don't do something too stupid. So in this window, I have a Netcat listener. In this window, I'm going to browse to some URL that a trusted person has given me. Okay. So I wonder why this web page is taking so long. Must be this crappy 3G network. So anyway, oh man, my browser, what happened? So meanwhile, on my Netcat window, I'm owning it. So. Hold on. I think I'm done basically, but oh yeah, I guess I'll just skip this part. But basically, you can do what the browser can do. You can write interesting payloads. Here's a payload I wrote that's C. The slide again, you can check it out later. It tells you how to write this payload such that you can get the GPS coordinates, and this is something you can do from the browser. And so you can watch, where the person's going, and you can see the bottom. Like at first, I X'd out the GPS coordinates because not only did it have like the GPS coordinates of my house, it had the GPS coordinates of like the corner of the house where I was sitting. So I was like, whoa. Okay, so thanks to a couple guys I worked with on this, and there's my email address. That's it. Thanks. How you doing?
Okay. I said to tell you I shouldn't talk to you.
Who's that?
Heidi?
Oh, okay. I got to scoot. There's a feedback form, and Heidi asks that you find her and talk to her. Okay.